We're now starting similarity because we're working to, so you guys did dilations, which you'll get in their sheet today. Well, we'll see how we do with time. We're now starting similarity, not the congruency. So similarity, they're now going to be given side lanes and maybe angles or arcs, and you have to tell me whether or not the two triangles are similar. Okay, so how do you do that? The way you prove similarity in triangles, and by the way, similar has this wave, right? So if I tell you this triangle is similar to that triangle, it's that wave, right? Cody, Seth, turn around. Now on this table. Okay, so look, so if we're looking at question 1, 2, 3, and 4, it states, state if the triangles in each pair are similar. Okay, your only way you can prove two triangles are similar are angle, angle, side, 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 angle, side, or not similar. These are our options. So we're going to go through these 4 together. Seth, Cody, go to the other table. Okay, so here we go. Okay, look. You have PQR is similar to BCD. Tell me how. Okay, so if you guys have, I'm trying to find colors that work. All right. If I look at B, this angle B is number 1 in the first position. Angle P is in the first position, right? B and P. And you can see 2 arcs, 2 arcs. So they have the same number of arcs. And so, yes, they're congruent, right? They're the same. And so that gives me an A, right? Arcs are A's. You guys will go through this problem really quickly, and I'm like going to talk through it, okay? All right, so now look at the second one. C is the second, right? And it has 3 arcs. And Q is the second, right, vertex in the name. And here's my 3 arcs. And so they match. 3 arcs, 3 arcs. They're both in the second position. And so there's my second A. And so are these two triangles similar? Yes, by angle, angle. So just like you guys took your test last week or 2 weeks ago, where you had a list longer, like you had 7 choices. Here you're only looking at 4. But for the sides, you have to prove fractions. You have to prove that there's a scale factor, a consistent scale factor. Okay, so now look at 2. All right, you have 16, 16, 12, and 11. So some of you might look at this and right off the bat say, you guys say yes or no? No. Why do you say no? Huh?
16.
Yeah, right? 16, 16 are the same number, but 12, 11, like they have different numbers. Okay, so the way you would prove it is you would have to prove a fraction. So this one is leaning towards side angle side, but like you said, it's going to fail. Okay, so this is how you fail it. You have BC or CB are the first 2 letters. CS are the first 2 letters. So BC correlates to CS, and so my ratio, and I'm going to go big to small. So I'll go big over small. So 16 over 12. And then the other side is AC and CT. So the first and the third, right? So AC, TC, and I get 16 over 11 if I'm going big over small. And so if you can prove these 2 ratios are identical, it's a yes. If they're different, it's a no. And so like you guys said, it isn't. It's a fail. Because 16 over 12 is 16, 12 is 4/3, right? And 16/11 is, well, 16/11. So if you were to write, those fractions are different. right? They're not the same reduced fraction. And so because of that, it's a fail, and so it's not similar. So to prove similarity, you have to prove the S's. They're no longer tick marks. You have to prove the ratio, so they're going to be numbers. Keep going? Yeah. Okay. Number 3. Okay, so you guys haven't worked with parallel lines a whole lot. Okay, so look. Vertical angles, this angle is equal to this one, and so that gives me an A, right? Vertical angles. That was on your last test. All right, so now if you guys have 2 parallel lines, right, because that's what arrowheads mean. These little arrowheads mean parallel lines, which gives you alternate interior angles. They give you A's. If you see an arrowhead, it's giving you an A. Arrowhead, A, angles, okay? So if these 2 are parallel lines cut by a transversal, then these are alternate interior angles, and that's an A. And so this is, yes, they are similar by angle. I'm going to be like Harlan's eating pretzels.
I don't have a paper.
Oh, I skipped you? Oh my gosh. I know. You guys, let me know if I skipped you. Wait, did you get one?
Yeah, I have it.
Oh, he took yours then.
Nope, my bad.
Okay, and I didn't give Josh one. Okay, so 4. All right, so look. See how there's 3 side lanes? So obviously this is leaning to side, side, side. But is it going to fail or is it going to pass? The only way it passes is if you can prove our 3 ratios are all equal. If they're equal, it's a yes. If it's not equal, if only one of them isn't equal, it's a fail. All right, so you want to go big, small, or small, big? Big, small? Okay, so we'll go big on top, small on the bottom. All right, so I have ML to CD. So ML to CD gives me 63 over 29. And then LK to DE, LK DE is 5424. And then MK CE. And so that's 3617. And right off the bat, is it a yes or a no? It's a no, you can tell, right? Because look, 17 is a prime number. That's 17. 29 is a prime number. You're not going to be able to reduce these 2. All right. So what is 63 divided by 29? I get 2.17. Okay, what's 54 divided by 24? 2.25. And already it's a fail. And what's 36 divided by 17? 2.12. So look, here I left, here I left them as fractions. Maybe you're okay with fractions, you understand fractions. But you're welcome to take it down to decimals. Just be careful that you don't round. Like here, I could have rounded to 2.2. Here, what if you left it at 2.2 and you'd be like, oh yeah, it's a yes. No. Make sure it has to be an identical number. So ideally, fractions, bless you, is a better check. But if you want to go to decimals, you can. That's it. This is how you prove similarity with triangles. It's angle, angle. You can just go by numbers or tick marks, so these are really easy. But in order to prove your S's, you have to prove a similar, equal, identical fraction. You got to prove a scale factor. Okay, so if you look at 5 and 6, because I'll stop the video right now. Okay, 5 and 6 are leaning you to side angle side, which means you should be able to tell really quickly if you have an A. But the S's on both of these, you have to prove that the ratios are identical. That's what you have to prove. And if you can prove these two fractions are equal, it's side angle side. If you can prove these two are equal, it's side angle side, because then whatever that ratio is, that's your fraction. That's your scale factor, okay? All right, and again, it's up to you guys. Do you want to go big, small, or small, big? Just you decide, okay? All right, let me stop the video before it gets long.
Yeah.